Hey everyone, John Frechette here, co-founder and CEO of Mora, Moara.io, stands for Mother of All Research Assistants. Today we're going to talk about citation management. I'll mention most videos about AI and research focus on reading and writing, summarizing papers, drafting sections. Very few people seem to talk about the layer underneath. That's your reference library. Let's call that your core kind of backbone or infrastructure of your paper. If your citations are messy, everything downstream is much more difficult. The way to articulate this is to say your reference library is only as good as your metadata. And indeed, in a typical reference manager, let's say pre-AI, pre-newer technologies, it's very, very messy. Let me just give you a couple examples. As we all know, if you're trying to, Google Scholar is probably, seems to me, the number one most popular literature search engine. You've got some newer ones. You have some library technologies like Scopus and Web of Science, and then you have PubMed for health science. But I would imagine this is the most popular search engine. The challenge you've got here is kind of twofold. One is very, very difficult to save citations down from Google Scholar. And secondly, even if you find an interesting way to do that, Google Scholar natively only has certain metadata. And it's pretty much everything you see here. If you tear into the back end of Google Scholar, this is all you've got. You've got title, URL, snippet, citation count, author, journal, and year. And what are the key things missing? The full abstract. You only have snippets. So getting the full abstract requires some additional technologies. And then DOIs. If we want to do anything related to finding additional fields from these papers, such as getting a better handle on their study design, the control variables they use, their identifiers, digital identifiers, we have to grab as a baseline DOIs. That's something you can't do natively here. Similarly, even when we do manage to sort of cobble together a library, what we find is that it is incredibly messy. There's very little attention that frankly has been paid to. There's a lot of great things about existing reference managers, but very little attention has been paid to user experience. And indeed, very little attention has been paid to integrations in AI in, let's say, the last 5 years. And so really the question comes down to how can we get and clean metadata so that we have an awesome reference management library that's also very easy to use. How do we manage our citations better? Typically, you fix this by hand. Yes, there's some deduping in a lot of reference managers, but then you end up with duplicates. You end up with, again, a lot of missing data, particularly if you're importing PDFs. If you bring in PDFs, you're not going to end up with things like citation counts or DOIs. And so the question becomes, once again, given we are likely going to be gathering literature from a variety of sources, how do we make that all very clean and easy to use? Before I show you my own workflow, I'll talk through what I think the 3 problems that are most interesting to me in this space are. The first one is metadata gap. As I just mentioned, incomplete records coming from different sources. The ways to fix that, spoiler alert, are with great integrations to Crossref, Semantic Scholar, and then also some of the publicly available, open source LLMs that we can use. The second is what I'll call a matching problem. If you have a library with 100, 1,000, or even just 20 citations, let's say, if you're making a particular argument or you're trying to assert a directional finding in the literature, actually matching the kind of mechanically the citations and their key conclusions to those findings, that itself is a fairly, again, mechanical, tactical cataloging exercise. That's a little bit less of a critical thinking exercise. And I think that is also an area where if you can get some synthesis going on your library, that's a great application of using AI in a reference management context. And then finally, I know people talk about this often, that research should not be a solo sport. It's a team sport. And so I do think there's a solo problem when it comes to reference management. Very few, yes, you've got open libraries in some contexts, but for the most part, everyone has their own reference manager, even if they're working with a team on a project or a paper, and they really don't have much collaboration that they use the reference managers for. They use other tools for that, like email, like shared Google Docs. And my view is reference management should really be itself more of a team sport. Okay, so let me show you how I deal with these problems. I will jump into Mora, Moara.io. Full disclosure, that's the tool I work on. It's a tool I use for reference management. Having said that, there are many different AI-powered reference managers out there and literature review tools. In this case, why I particularly obviously enjoy using our tools, because if you do have a Zapier library set up, you can actually easily integrate your account, two-click process, and import all of your libraries. In this case, I'm going to stick with the Google Scholar example, and maybe the PDF example as well. I'm going to go ahead and build my library, and I will use for now the example of just I typically use economics examples, so effects of tariffs on international trade. And once again, Google Scholar, we know natively does not have DOIs, does not have abstract. So what do we do on our end? We're actually going out and grabbing those things. I'm going to save down the top 10 just to be quick, and then I can go through a little bit of a title and abstract screening if I need to. And as we can see, even though abstracts didn't previously exist in Google Scholar, we've gone ahead and used our models, which start generally with finding DOIs. We've got a DOI finder. First it's dedupe, then it's finding DOIs. Then you are using DOIs to check Crossref. If it's not there, it's a waterfall that falls over to OpenAlex. If it's not there, it falls over to Semantic Scholar. Not there, finally, it falls over to Claude. That is how we're able to handle, for instance, working papers that don't have DOIs, is very well-trained Claude models that actually go out and find those. So let's jump back to the library. I'm going to go ahead and rename this Effects of Tariffs on International Trade. The question is, how do you actually do matching, solve the matching problem? You can use our library chat, or you can export. I'm going to export as a CSV. And when I open up the Excel, this is what it looks like. Frankly, I'm just going to go ahead and grab what I view as the most important fields here: title, author, journal year, DOI, URL, abstract, and citation count. Abstract is really what we're looking for when it comes to your initial title and abstract screening matching. Again, you can use library chat on our site, or you can go ahead and just use Claude. And maybe in the case of Claude, what I'll write is identify themes described library. You can import the Excel doc if you want, or what I usually do is just copy and paste it in here. Alternatively, if you've already started to write, all you have to do, of course, is plug in an assertion or argument. Assuming you've come to that argument, you can put in that argument and say, give me the exact citations that match this argument. So long as your context window is small enough, you should get a pretty darn good result here. We can see what the output starts to look like. You've got the 10 papers that are in our library, key themes being mentioned. Here, you could also work backwards, right? In the past, I've talked about a top-down approach to preparing a paper or a bottom-up approach. This one would be a little bit more bottom-up. You're starting with all of your citations, and you're sort of putting together sporadic notes, and then using all of that to aggregating it, coming up with your outline, coming up with your key arguments. So that's all really you have to do to solve the matching problem. Again, in a different context, you might put in your argument, positive effect, negative effect, whatever, and ask for those in-text citations to include. Now let's head back to the library and talk about the last issue, which is the solo problem, or the problem of really trying to enable collaboration. So how do we do that? Very straightforward. We're going to go into our collaboration tab. You can also access this right through your library. And I'm just going to type in a name. I'll put my colleague Seth. Viewer, I'll make him an editor, send an invite, and Seth gets an invite that says John has invited you to a library. He can click into it. And then you can do all sorts of things together. Okay, you can go through a full workflow of screening, full text review, etc., or right there in the library, you can mark priority levels, tag papers, record notes, etc. So here's the big takeaway. AI for reference management is not about necessarily evidence synthesis or summarizing papers. It's much more about fixing your infrastructure, your metadata, organization, structure, so that everything else you do with your papers actually works very well. Clean metadata means accurate citations. Structured libraries mean you can actually use AI to help you write in an effective and ethical way. And collaborative workflows means you are not doing discovery and writing alone. If you want to see how I use AI to actually go through the writing process, or really go through a whole bunch of different workflows like title and abstract screening, please visit and subscribe to our YouTube page. We're just getting it going. And I'll put the link to those specific sessions in the description as well. Really appreciate the time. Thanks everyone for watching.